Okay, we're starting our new unit, Unit 1.4, which is over key features, linear key features, and linear transformations. We're not going to worry about linear transformations right now, but we are going to talk about linear key features. And so what a key feature is what are the things about linear functions that make them linear functions? And there's a bunch of them. There's a bunch of stuff we're going to talk about that's very specific to linear functions in this unit. There's a lot in this unit, so you need to make sure you stay caught up. The first thing we're going to talk about is functions. Now, you guys probably remember functions because you talked about them last year. So, last year when you talked about them, you probably talked about functions, but I'm not sure how much time you spent on relations, okay? So, anything that I can graph is a relation. An ordered pair, any set of ordered pairs is a relation, okay? And we just got done talking about scatter plots. Scatter plots show a relationship. So, that's why scatter plots are a type of relation. We're showing how two things are related to each other, all right? Now, a function is a type of relation, so it's a set of ordered pairs that meets specific characteristics, and that characteristic is none of the x values can be repeated. So let's think about a vending machine when we think about this. Okay, so let's pretend we have this vending machine right here, and it's got 6 buttons, okay? And if I press button 1, sorry, I'm going to have to turn sideways here. If I press button 1, I get a Coke. I press button 2, I get a Sprite. I press button 3, and I get a root beer. I press button 4, I get Coke Zero. I press 5, I get Dr. Pepper. I personally love root beer, so my Coke machine is going to have 2 buttons that give me root beer. Okay? So, this is a function. So, what a function is something that is predictable. So, functions are predictable. Okay, what does that mean? What that means is, if I push a button, there's only one possible thing that could happen. If I have one input, so I input a 1 into the Coke machine, there's only one choice for what I can get out of that Coke machine. Okay? If I hit a 1, I get a Coke. If I hit a 2, I get a Sprite. If I hit a 3, I get a root beer. 4 is a Coke Zero, 5 is a Dr. Pepper, 6 is a root beer. Now I have 2 buttons that give me root beer, but what do I know? If I push either one of those buttons, I'm going to get root beer. Okay? If we look at this, if we drew this as a table, okay, and we're just going to do this really quickly here, and we're only going to kind of we're going to summarize, okay? So 1 would give me a Coke, 2 would give me a Sprite. We might need a little more room, so I'm going to open this up. Okay, 3 gives me root beer, 4 gives me Coke Zero, 5 gives me Dr. Pepper, 6 gives me root beer. Do any of these numbers repeat? None of these x values repeat, meaning each x value only has one y associated with it, and that's what makes this a function, because each button only gives one option. Each button only gives one option. Okay? So that's a function. This Coke machine is functioning. It's working. It's functioning. Now, this Coke machine over here, not functioning. Let's talk about it. So far, this Coke machine looks good, right? If I push the 1 button, I get a Sprite. I push the 2 button, 1 button, I get a Coke. 2 button, I get a Sprite. 3 button, I get a root beer. Or I get a Coke Zero. Maybe I get a Coke Zero. Or maybe I get a can of green beans. Why? I don't know. This is a weird Coke machine. I know that looks like green bears, but it's beans, okay? Maybe I get a can of Pringles. Or maybe an angry cat jumps out and bites me in the face. Is this machine working? This machine is not functioning, okay? Because when I hit a button, the 1 button's good, the 2 button's good, but the 3 button is not predictable. I'm sure you guys, you may or may not have, but I'm sure you guys have seen those. Sometimes they have these vending machines and they have like a coil, and then there's like stuff in the coil, and then like halfway down the coil, like it starts giving you something else. Imagine that, except you can't see what's coming. Okay, that's what's happening here, okay? So this machine is not functioning. So once again, let's take a look at what this would look like in a table, okay? And just to be clear, this is my X. The first one is my X. The second one is my Y. This is my input or my button, and this is my output or what comes out of the Coke machine, okay? So for this one, if I hit the 1 button, I get a Coke. Yay me. If I hit the 2 button, I get a Sprite. Very exciting. If I hit the 3 button, I get a root beer. If I hit the 3 button, I could also get a Coke Zero. If I hit the 3 button, I could also get green beans. If I hit the 3 button, I could also get Pringles. If I hit the 3 button, I could also get maimed by a cat. Okay? All of these things could happen if I hit the 3 button. Because I see this 3 button giving me multiple options, this machine's not functioning. Okay? So, button 3 has multiple options, which are multiple Y values that go with it. And that's what that looks like when I put it in a table. Our strategy for functions is, when in doubt, table it out. If I put this in a table and I put what this mapping is doing, it becomes really obvious that I have not a function. Now, when I look at functions, I don't worry about what's happening in Y. I don't care that I have root beer twice, because these buttons are predictable. These X values are predictable. I know if I hit the 3, there's only one choice. If I hit the 6, there's only one choice. They happen to be the same choice, but I know what's going to happen when I hit that 6 button. This isn't a function because when I hit the 3 button, there's like, I even forgot to draw an arrow to the Pringles. There's like 5 different things that could happen. That's not okay. When I put my money in and I want a root beer, I want a root beer. I don't want a Coke Zero or green beans or Pringles or an angry cat. Okay? So that's what makes something a function. Now, are we going to see a Coke machine on the test? Absolutely not. So let's take a look over here at what we might see. All right. So the first thing we're going to talk about are mapping diagrams. Okay, this is a mapping diagram. The thing with the bubbles, it's called a mapping diagram. Okay, I know this is a little blurry, and I'm sorry and not sorry about that. Okay, so in a mapping diagram, remember we have an input or an X button and an output button. Okay, I can't have more than one line coming off of an input. And again, we'll see what that looks like when we draw a table. Okay, so on this one has one arrow. So if I look, this one only has one arrow coming off of it, one arrow coming off of it, one arrow coming off of it, one arrow coming off of it. This is a function. So again, a function for a mapping diagram would have no X bubble with more. Make that look normal because y'all are going to be like, I couldn't read it, Mrs. Deal. With more than one line off it. So with more than one line coming off of it. Okay, so this one, these only have one line coming off of it. Well, what does that look like in a table? So really quick, this is a function. Well, in a table, here's what that would look like. I would have -4 pointing to 9, -1 pointing to -6, 1 pointing to -6, and 3 pointing to 11. Here's the strategy that we're going to use. We're going to squiggle out the Y. We don't care what's happening in the Y, okay? So let's write that down here. Squiggle out the Y. So we're going to squiggle out the Y, okay? I squiggled out the Y, and now I look. Do I have more than one of the same number? I do not. Now look, I've got this 1 and this -1, but different sign means different number. So yeah, I've got a -1 and a +1, but they're not the same number. That means I owe $1, that means I have $1. Those are two entirely different things. Okay? Now let's look at this one, because this one is not a function. Okay, this one is not a function. All right? So for this one, if I drew my little table, X, Y, I have 3 pointing at 4. I have 3 pointing at -4. I have 5 pointing at 0. I have 6 pointing at 2. And then I squiggle out my Y's. Well, uh-oh, look at that right there. I've got 2 3s that are the same. That means this is not a function. two x's that are the same, it's not a function, okay? We just kind of talked about what to do with a table, but the same thing. Our strategy is we squiggle out the y, and I look for repeated numbers. Once again, I have a -3 and a +3. They're different numbers. -1 and a +1, they're different numbers. This one is a function. Here, I squiggle out the y, and I look. I have an 8, a 3, and I've got 2 5s. Uh-oh, not a function. Now, for this one, I have another strategy. I need a prop. So I'm going to pause this just for a second and come back. Okay, I've got my prop. My prop is a highlighter. I am like madly in love with highlighters. I'm married, but he understands. So, okay, first of all, so there's two different strategies. So there's one strategy I use when there's dots, and there's one strategy I use when it's like a connected or a line or a squiggle or a circle or something, okay? So when I see dots just graphed, here's what I do. So remember, you may remember this or you may not. We had this thing called the vertical line test. And what that is you take a vertical line and you move it along your graph. If at any point, now again, we're not talking about the grid, we're talking about the points, the thing that's graphed on it. So if at any point you see a dot that's hitting your line or your pencil or your sticky note twice, it's not a function. Now this one I don't see that happening. If you look over here, oh, right there, there's 2 dots. That means not a function. If I keep going, there's 2 dots. So they're on the same vertical line. And this is called the vertical line test, okay? And we call this, like if you're trying to justify it, we call this VLT, which is the vertical line test. This is why up until now we haven't talked about functions. We talked about vertical lines, right? X, vuxes. They are not functions. They are not linear functions. They're linear equations. That's neither here nor there. So a vertical line is so not a function that we use it to see if other things are functions. All right. What you can also do is you can make a vertical line with your highlighter. You see how my vertical lines, I've got 5 lines and 5 dots. That means this is a function. But see, look here. I've got 1, 2, 3, 4, 5. So here I've got 5 lines, 5 dots. That means it passes the vertical line test. Function. This one here I've got 5 lines, and I've got 1, 2, 3, 4, 5, 6, 7 dots. I got more dots than lines. This is not a function. Now this works on anything. So let's just for the heck of it, let's look at this mapping diagram just so that we have a circle. Okay, if I draw a vertical line, look at that. It's touching there, and it's touching there. This circle is not a function, okay? Because a vertical line touches this point in 2 places. If it ever touches it in 2 places, it's not a function, okay? And then for the last one, it's ordered pairs, right? Okay, so we know about ordered pairs. Now, just for grinsies, we're going to put these in a horizontal table instead of a vertical table because I know how much we love those. What I also know is almost every time they've asked about these on the STAR, they've been in a horizontal table. So let's see what that looks like. So let's look at this one. We're going to put this in a horizontal table. So we have X, Y. I'm sorry, that line is not straight. I'm the teacher that you get. You're going to be all right. So we have -6, 8, 3, 1, 2, 18, and 4, 7. What's our strategy? We squiggle out the Y, and then we look. Do I have any X values that repeat? Nope. So this is a function. Okay. Now likewise, let's do this guy right here. Let's put this one in a table. X, Y. So I have -3, 0, 2, 1, 2, 4, and 6, 5. And we squiggle out the Y. Uh-oh, look at that. I have 2 listed twice in my X column. Not a function. Okay? And that's what we need to know about functions. So if you have any questions, let me know.